All right, let's look at the homework 15.6, problem number 8. All right, so let's do this problem. All right, so we have this surface. I'm going to call this guy F. You don't really have to do that, but I'm going to do it anyway. So you have F. All right, so I'm going to take the partial derivative of F with respect to x, and that would be e to the negative x squared minus y squared. Partial of that, so chain rule, negative 2x, right? And then partial with respect to y would be same thing, e to the negative x squared minus y squared. And the chain rule, partial of that is negative 2y, right? So if you compute the square root of partial of x squared, and partial of with respect to y squared plus 1. Alright, so this is going to be square root of, alright, so we have negative 2x squared, so it's going to be 4x squared, and then you have a e to the negative, I'm going to write it as negative 2, and I'm going to write it as a quantity x squared plus y squared. This will make it easier to convert it to polar coordinates and square that. So it's going to be 4y squared and e to the negative x squared. Oh, actually, I have to square that one too, right? So it's a negative 2. Then you have x squared plus y squared. And then we have a plus 1. Right? And then I'm gonna, let's see, pull out 4 there. All right, 4 is in common. All right, then you have x squared plus y squared. So I'm gonna actually go ahead and rewrite it as a r squared. All right, then you have e to the negative 2. And then you have another x squared plus y squared. So I'm gonna write it as r squared. And then plus 1. All right. So if you want to find the surface area, and we can set up a double integral. Alright, so integrand would be just a square root of, and 4 r squared e to the negative 2 r squared, and plus 1. And then area element is r dr d theta, right? Then disk is x squared plus y squared is less than or equal to 16, so the radius is 4, so r goes from 0 to 4, right? Then to cover the entire disk, theta has to go from 0 to 2 pi, right? Alright, so since this is separable, so let's just do the theta one. So you have integral from 0 to 2 pi, and then you have a d theta. Then we can just do times everything else. So from 0 to 4, and square root of 4r squared e to the negative 2r squared plus 1 dr. And there's going to be r there, right? So let's compute that, and we know that here, this is easy to compute. This is going to be just a 2 pi, right? So we just need to compute that using a Geogebra, right? So let's open up a Geogebra. All right, so we need to type in, we need to get the decimal value. So I'm going to just say numeric first, right? And then we're going to have to do 2 pi times integral. Right, so here I have an integral. Right, so integrand is r times square root of, right, 4r squared e to the negative 2r squared. Then we have plus 1, and variable is r, and starting number is 0. Ending number is 4. So then we need to, let's see, I'm going to put the 4 so we need the 4 decimal places, right? Get that. Right, actually, I need 2 more. So we have here, so 6, right? So you can see that the value is 51.6822, right? So let's type it in. All right, oh, hold on a sec. All right. All right, so what we got was 51.6822. All right, so let's submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.